This lecture is on finding limits of rational functions that are undefined at the point that x is approaching. A business calculus webinar by Dr. Archie W. Earl Sr. So we are looking at rational functions, algebraic fractions, functions defined by algebraic fractions in this lecture. These are the steps that are involved in finding the limit of a rational function that is undefined at the point that x is approaching. Step number 1. Rationalize the numerator if there is a square root in the numerator by multiplying the numerator and denominator by its conjugate. That's step number 1. Step number 2. Simplify the rational expression. And finally, step number 3, find the limit of the resulting rational expression. Feel free to stop the tape and copy down the steps in your notebook so that you will have those steps in your notebook as we proceed, and you can refer back to those steps. Once again, if you have a rational function that is undefined at the point that x is approaching, number 1, if there's a square root in the numerator, you have to rationalize the numerator by multiplying numerator and denominator by the conjugate of the numerator. Step number 2, you simplify the rational expression. Step number 3, you find the limit of the resulting rational expression. In our last class, we looked at some examples wherein this was the case. The number that x was approaching made the function undefined. So those problems 49 and 51 in our last lecture, we can use this technique to find the limit of those functions. Feel free to stop the tape at any time. Here's an example. Example 9. We want to find the limit as x approaches 4 of the square root of x minus 2 over x minus 4. If I look at my denominator, you see here x is approaching 4. If I look at my denominator, if I substitute a 4 in this function that we have here, in my denominator I would have 4 minus 4, which is 0. That would give me 0 in my denominator, which would make the function undefined. So this tells me that I have to use the procedure that we just mentioned. This tells me that I'm going to have to rationalize the numerator if I have a square root in my numerator. Then I'm going to have to simplify the rational expression, which means I have to factor my numerator, factor my denominator, and then cancel. And then last but not least, I have to find the limit of the resulting rational expression. So my numerator here is the square root of x minus 2. What's the conjugate of the square root of x minus 2? Think about it. What would be the conjugate of the square root of x minus 2? You had conjugates in your previous math classes. So you should be able to tell me what the conjugate of the square root of x minus 2 is. What is it? If you said the square root of x plus 2, you're correct. That's the conjugate of the square root of x minus 2. So that means that I'm going to have to multiply this rational expression, the numerator and denominator, by the square root of x plus 2. So that's what I've done here. I've taken my original problem and I'm multiplying the numerator by the square root of x plus 2 and the denominator by the square root of x plus 2. And we can use the FOIL method to do this. Multiply the first two, we get the square root of x times the square root of x, which would give us the square root of x quantity squared. And the square root of x quantity squared would be just plain x. Then we multiply the outside two. Okay, the outside two, you have the square root of x times 2. Those are the outside two. And when we multiply those two together, we get 2 times the square root of x. Then we multiply the inside two, which is negative 2 times the square root of 2. That would give us negative 2 square roots of 2. Now, if you have a positive 2 square roots of 2 and you subtract 2 square roots of 2 from it, that will give you 0. So these two will cancel. So we just get x minus 4 for our numerator. So that's what we have here. The numerator, after we rationalize the numerator, we get x minus 4. The numerator is now a rational number. We have gotten rid of the square root in the numerator. So you have to do that if you have a square root in your numerator. If we didn't have a square root in our numerator, we wouldn't have to rationalize our numerator. We would skip step 1 and go to step 2. So we've done that now. We rationalize our numerator. Now in our denominator, we just have x minus 4 times the square root of x plus 2. We just leave it like that. You see, x minus 4 in parentheses times the square root of x plus 2 in parentheses. Now we would factor our numerator and denominator and then cancel. But in this case, our numerator and denominator, they are already factored. So we don't have to factor them. All we have to do is cancel. And as you can see here, we have x minus 4 in our numerator, x minus 4 in our denominator. So we can cancel the x minus 4. Now that means that everything up top cancels out. If everything cancels in a fraction, numerator or denominator, there's understood to be a 1 left there. So that's why we have this 1 in our numerator, because everything cancels in our numerator. We know that there's understood to be left a 1 there. So we end up with 1 over the square root of x plus 2. So that's what we have to find the limit of. We find the limit of 1 over the square root of x plus 2 as x approaches 4. And that's what we have here. That's what we're really finding after we rationalize our numerator and then simplify or reduce the rational expression. So now we can just use our formulas that we used before. The limit of the quotient is the limit of the numerator divided by the limit of the denominator. So we take the limit of the numerator as x approaches 4. The numerator is a constant. So the limit of this numerator as x approaches 4 would be 1. Remember, the limit of a constant is the constant itself. So the limit of 1 as x approaches 4 would be equal to 1. So that's what we have in our numerator. Now for our denominator, the limit of the square root of x plus 2 as x. For the limit of the denominator, we have the limit of the square root of x plus 2 as x approaches 4. And here we can just substitute the 4 in for x to find that limit. So we get the square root of 4 plus 2 for our denominator. And the square root of 4, of course, is 2. And that would give us 2 plus 2, which is 4, giving us a final answer of 1/4. And this concludes our webinar on finding the limit of rational functions wherein x approaches a value wherein the function is undefined. And this webinar, once again, is available on demand. Just write me at awearl@nsu.edu. Have a great day.